right, everyone. It's already time for the next talk. So if everybody could take a seat, that would be great. Because we have a really cool talk lined up for you next. It's going to be by Pawel over here. And he just told me that as a kid, he used to like games and he also used to like sports. So that got together and now he's into... I keep going. And and that makes him go get into the fantasy basketball. And about this, he's going to tell us something about now. So I'll give the floor to you. Good luck.
Thank you. Thank you for the introduction. Thank you, everyone, for coming. So before I start, question to the crowd: who likes basketball? Yeah, decent group, bigger than expected. Yeah, who plays any fantasy games? And who works with optimization algorithms? Any kind? Okay, that's good, because no one will fact check me on the stuff I'll be talking about. Let's move on. Okay, this is the short agenda, what I will be talking about. So, yeah, we'll start about the basketball, what it is, because not everyone raised their hand. Then I'll be talking about fantasy NBA, which is, slightly different to the games most of people play in Europe, in our part of the world. Then a bit about integer programming, then PuLP, what it is. Then there's supposed to be demo, but there won't be, and there will be just displayed code on the screen, and I'll be talking about this. So less exciting, but also risk-free for me, because nothing will fail. And at the end, you can go to the next, presentation or home, whatever you want. Okay, game of basketball. So this is the basketball, more or less. There are some passes, people dribble, passes, people take shots, and this for ages was described by StatsKeeper. So I think basketball is quite advanced comparing to other sports at collecting at least some basic stats about what's happening on the court. I think that's the replay of the same action. But basically, what's been collected? So most of those stats exist for at least 60 years, and they're like, I think, whole history of the NBA is actually collected with this kind of stats. There are some new ones that were added later with the development of the sport. So, for example, blocks were added slightly later. Then, obviously, three-point shot was added later in the future because it didn't exist before. So it kind of skew the game. But yeah, this has been collected. There was a person at the arena that was counting each of those things to get better context of it. So if we compare to something we are, I guess, slightly more familiar with, like football, we didn't really collect this as much historically. So we didn't collect shots taken. Was usually goals, yellow cards, subs, and that was it. So yeah, it was slightly more advanced. I think that's a good thing. I think the whole like sports analytic revolution wouldn't happen without the basketball. I think basketball is it's easier sport to actually apply some stuff, and I think applying sports analytics, advanced data science on basketball proved to other sports that this can be done in like less isolated environment than baseball. So I think all the breakthroughs we can thank the basketball for them in a way. All right, let's move to fantasy basketball. So basically, those stats I just showed you, some people ages ago decided that actually fun, and based on real life outcome of basketball games and what players producing on the court, we can set up some games and just have fun and play day to day, week to week on some problems. So it's quite popular. It's estimated that right now 11 million players in North America only play it. Comparing to Fantasy Premier League, for example, that I guess is the most popular in the world, in Europe, in the non-American world, non-American sports world. Okay, that's the phrasing, which is about 11 millions as well. But yeah, as I said, this counts only North America. So also externally, there is wide range of formats and rules, which I'll be talking about briefly. And then it's kind of entry points for sports betting. So I think two biggest fantasy basketball, like fantasy sports companies right now are huge bookmakers in US. So it helped them to sneak in and legalize gambling, which is interesting social case, I would say. Okay, so if three league types, I would say. Most of the people that play, they play season long, and I think that's the longest standing format of the playing. So we play the full season, 6 months. You pick a team once, so it's either through draft or there are some different ways we're talking about them, and you just adjust your lineups and go through stuff trying to win your either weekly matchup or trying to collect as many points over the season. Depends on the rules. Then daily stuff. Daily stuff is much simpler, so you can play for a given day. So let's say there is 6 games tonight. There will be 20 teams playing. From each team, 12 players available to pick. There will be some salary cap, and you just pick the players you think they will collect as much stats as possible, and then whoever from your group gets the most points, they win. And this started as a skill game, and you can put some money into the bucket, and then whoever is in top 100 will get the money out of it back, and everyone else just losing their money. And the best ball, I think it's not that popular. So you basically draft, and then you don't do nothing, you just settle. So it's kind of like fantasy Premier League players that just pick their squad at the beginning of the season. They don't do anything at all for the rest of the season. So those are league types. Then the formats. Okay, so the easiest one is points. So every statistics that I was showing you has assigned some weight to them. So points is just 1. Rebounds will be 1.2. Assists will be 1.5 or 2. Steals and blocks will be 3. And this is basically to accommodate players with different skill set and just like add some weights. Then there is Roto. Roto is interesting because you have multiple categories. So all those things I was talking about, points, rebounds, assists, those are categories. And your goal is to win as many categories as possible or be as high as possible in each category. So it's a lot more complex instead of how you preparing for a match. So imagine fantasy Premier League where goals, assists, and tackles are separate things, and you want to be as high as possible in each of them. Very fun format. Then head-to-head, it takes from categories, but you play weekly against your opponent, so there's a matchup thing. So try to beat your opponent. Then head-to-head points, which is playing on points, but on weekly basis. Yeah, and head-to-head categories will be similar. Yes. And draft types. Okay, so there are a few draft types. In Fantasy Premier League, we have a budget. We pick a team, and our main constraint, or like only constraint, is just player positions and budget. Here we play inside the league, so it's like draft in Fantasy Premier League. It actually exists. I forgot about this. But yeah, you can either like snake draft, you can auction draft, so you pay for a player. Like you just assume some value, you assign value to the player, and this is how much you want to pay. And if no one outbids you, you get the player on your roster, and live with that. Then linear draft, which is not a snake. You just pick one, picks first every round. And salary cap, so it's for daily. So how it works is daily. There's this budget you can spend. Every player has assigned value, and you want to create the best possible team that gets you the most point within your budget constraints, but just on daily basis. So this is the quick intro to the fantasy and fantasy basketball. I think it's complex in a way that there's lots of different ways to play comparing to all other fantasy sports. So depending how much time you have, you can adjust for that and find something that can work for you. Then integer programming. So yeah, just short introduction. I'm not optimization expert, so I got into that just trying to solve some problems that I had. And not necessarily fantasy basketball problems, but I thought it would be good application to show how I actually use this, the whole concept of algorithms that are used in real world and can be applied to something more fun than business problems. Yeah, finding the best solution within constraints, define what you control, what you want, what limits you. I'll be showing how exactly this in the code. Then solver, so the algorithm behind this will guarantee the mathematical optimum. So we pick the best solution. I'll prove you that picks the best solution for my problems. And then it uses only addition, subtraction, and multiplication. So it's a simple way of approaching optimization. Okay, so PuLP. PuLP is the Python package that just, under the hood has all those algorithms. You add PuLP to your project using UV or PIP, whatever you prefer. Here's some additional articles that can be helpful into getting into this stuff. Here's just list of functions that we're going to use. As you see, quite short, but then I'll be showing the code. I'll be talking about this, and yeah, this is all you need. All the problems that I'll be showing, it's just all those 7 functions for my problems, 3 that we'll be talking about. So yeah, I think fairly easy way to intro. It's just a matter of defining the problem and finding a definition for it that can be limited within the constraints that linear or integer programming would expect from you. Okay, so we'll be talking 3 code examples. So this is kind of leading to the fake demo that there will be in a second. DSF, so daily fantasy. We have limited salary to use on our squad. Every player has the same budget and same access to the players. So you can pick from the pool of 500 players. You can pick whoever you want. Your only constraint is the budget, and the players are assigned to certain positions, which is important. Then head-to-head fantasy points. Player needs to score more fantasy points to win the week. The constraint is we don't have access to all the players because we play against other people who have their squads, so we cannot pick the players from their squads. But all the free agents that are available, you can pick from them and just find, if someone will work better than one of the players we already have on our squad. And then head-to-head category. So usually people play 9 categories, but for making it more digestible and also easier for me, we'll have 5 categories, because then the categories are, for example, 3-point accuracy, and it just makes it whole, I think, slightly messy. And this is how we're going to be solving our problems. Okay, this is the data. So if this was the demo and I was using the code right now, I'll tell you that positron is very nice IDE for doing data. And now I'll make some enemies in the crowd, but I like R very much. And this is what got me in the whole programming and data world. R got me there. So I'm very thankful for R. And people who created R still, they created positron, but they did it better than before, because right now you can use Python there, and you can also use Jupyter notebooks. So it's very cool. When you want to explore CSV files, all this kind of stuff, just click, you see you have all descriptions, all the distribution of things. You can see quickly how many nulls are in different columns. So I think much better way with interacting with CSV files than whatever Microsoft or Google have for their Excel spreadsheets. So this is the data that we're going to use. So we have player names, we have position they can play, so they are available to play only on those positions. We have salary that limits them. We have projected points, and that's right now important part is that I didn't really model projected points. So this is the monthly average for the last 30 days. So yeah, I didn't. This wasn't like data science problem. This wasn't like the projections problem. So I just picked something that's good enough, I guess. Just more to show you how it works and how the optimization works, not focusing on the projection side. Yeah, so that's the data, and then we have actual points, so we can actually see the value of the optimization that was done. Let's go to the next slide. Okay, so this is the code. As I said, we solving daily fantasy problems. So we have salary budget. It's over there. It's 50K, and we need to find players that will play on each of those 8 positions. Those positions are defined as point guard, shooting guard, small forward, power forward, center. Then we have guards. So this can be either point guard or shooting guard, and there's forward. It can be either small forward or power forward, and there is utility player who can be any position. And our goal is to create a team that will, score the most possible points out of this within the salary cap that we have here. So first thing we do, we define our problem, and our problem is maximization problem. So we try to maximize the value. Here's the function that we'll use to check if players are eligible to play on certain positions. And yeah, there are some small things. Oh yeah, and the position initially, okay, one player can be assigned to multiple positions, as you can see. So what we need to do initially is just change those positions to yeah, all the possible options they can be set on. Okay, so first of all, we define our objective terms. So we loop over all the players. We pick the player ID. We pick the projected points. So this is our value that we try to maximize. And then for every slot we have, we check if player's position is if player is available to play on, and we create our functions, so projections, and then we check the player ID and the slot. And when we create our list of objective terms, we assign this to LP sum because we try to get the sum, and we define this as a our goal. Then the next step is we loop over slot and we check if players are actually available to play on this particular position slot. So next prop variable that the next LP sum that we assign to our prop object, that's defined over here as our problem. We will be yeah, just limitations that we put on our optimizer. And yeah, then we go through all the player IDs and again assign the we checking if there is a player on the slot already, because if there is, we need to skip it. Then I had locked players. I'll be talking about this in a second. So basically, there's a case that maybe we want someone on our team, but initially optimizer wouldn't assign them. So you can actually, you know, force them to assign them. So this is the part that will do that, and we can do the same for exclusion our players. And there's the salary. We'll do all the calculation, and when we define the salary, we check if the salary cap is lower than what we defined, and this is defined by rules of the game. At the end, we just run the solve, and we will get some solution. Okay, so we got some lineup, and as I said, yeah, the values between projected and actual will be different because, you know, projections were not great, just averages, but projected points, you know, decent number, actual not that great, but this is mainly issue with the projections. And then we can see, like, for example, we have a player who we paid a lot, but he didn't play, he was injured. So when we know a player is, for example, injured, we can exclude them from the process. In the next step, we want to lock a player. So we lock in LeBron James. We have like this feeling that LeBron James will have a great night. We lock them true. This will change completely our lineup, as you can see, just because we had to accommodate the salary that he takes. And, you know, values are different. Projected points is lower because, you know, we added like extra constraint for optimizer. But the actual points are slightly better because, you know, LeBron performed very well comparing to money you had to pay for him. Then the next step, okay, I don't like Patrick Beverley. I wanted to remove him, so I removed him, and we got to, you know, similar projected points value, but the actual output is actually slightly better. So yeah, we had some extra constraints. We got there. If we had much better projections, this is the like if our projections were on point, this is the value we can get in projected points. So this is when we maximizing to our like very good projections, we're getting very high value, much higher than, you know, whatever we're getting. And if we manage to get this value, you know, get very good projections when we are inputting to optimizer, we would finish at the top for this day, and like, but in the top by a lot. Obviously, you need to have a good projections to actually make sense of it. And yeah, previous one, you know, we would be 40,000 out of 200,000 people who joined the game. Only top first 100K gets paid. So yeah, not great, but, you know, we need to work on our projections. Optimizer does its job. Next problem. So next problem is the fantasy points game. So as I said, you have a team. You draft this at the beginning of the season, and then you try to manage the team. You know, get players every week who will bring you more points, then remove players who will, you know, not get any points, and then just you want to be better than your opponent. For the sake of this kind of, you know, project, I didn't play it against opponent. I tried to play this against, you know, every week I try to get a better team than the team that I started the week with, kinda. So yeah, just trying to get better every week. Everyone should try to do this. Just get better every week. Yeah, okay, similar stuff. We importing, we have our roster constraints are different. We have a bench, so we can have a player benching that won't be playing in that particular week, but we want to keep them because we think there will be value in the future. I picked out of list of players, I picked those who are assigned to my team, so that's one constraint, or they don't have fantasy team, so fantasy team ID is null. Then some shenanigans to getting positions, actually unpacked from a string, and we do very similar thing. We maximize. Then we have our objective, so we again maximizing, and we need to make sure that we covering all the slots for our team. And there's less constraint because we don't have salary cap constraint anymore. So our constraint is just defined, I would say, in the third row of the code. So the player needs to be either on my team or free agent. That's the constraint we work with. The extra constraint other than positions. And we go to the results. So basically, this is the team that I started my week with. This is even without looking at the positions I have, so I'm ignoring the positions, I took the top players, and this is the number I'm getting of the points. And 608 is the number that I'm actually getting from players after applying optimizer on them. So as you can see, there's improvement. This actually works. So yeah, good job to the PuLP library. And we can go to the next problem. The next problem is this multiple categories. So we try to solve multiple things at the same time. So we try to maximize all the categories. We need to win at least 3 out of 5 to win the week in this particular game. So yeah, this is the data. Data is very similar, but now we have every statistics separate. Previously, we had them as a fantasy points as all together, applying some weights to them, and right now every statistic is separate. So we do the same. Okay, there's a shortcut there, so I just put the opponent projections there, but I wanted to manipulate some stuff and this is easier way to show you how Solver works in different setups. Here, very similar things are happening as before. We pick my team ID. We go through this stuff. Roster slots, similar as previously, actually the same as previously. Then we check eligibility. We define our problem, and we need to check if player is available for a slot. Then we want to win categories with binary problems, so we either win or not. Then we assign this, as a sum of winning to as our goal for a solver. And then we go with the limitations. So player needs to be eligible for their position. And then at the end we solve, and then we check if we actually beat the opponent in the category. Okay, so here are results. So actually, I defined this opponent over there. I just picked some numbers initially, kind of at random. And then you can see, I won 3 categories, but this is very artificial opponent, so it's not very real. But yeah, I want to check you something interesting. But yeah, optimizer works, and it's going to work in different ways depending on the values it tries to achieve. Because so optimizer doesn't work; it doesn't know by how much it's supposed to win something. So there are some funky stuff coming for it. But yeah, this is our first setup. We lost 2 categories, points and blocks. So in the next step, I got blocks lower to 15, and optimizer figure out it can still win the blocks. So you see it tried to get more blocks on the second try. So it got to the 15, even though on the first one it just stopped at 11 because it knew, okay, I couldn't reach the opponent anymore, so it doesn't matter. And it lower my oh, that's the wrong one. Lower my steals. It lower my assists, but I still won. That's good. So optimizer kinda can adjust the total output depending on the conditions put on it. Similar thing, I figure out that I can put the points. So just because the points are kinda in hierarchy are first, it will try to optimize for points first, and then it just ignores the block part. Yeah, even more than before. Real life examples, and yeah, I think that will be end. So some of them are real, and some of them could be used. So Google PageRank, there's a paper on it. Kidney exchange program, this even happens. There's a paper on it from Eindhoven. So that's nice. Sports scheduling, there are some rumors teams are doing that, not 100% confirmed. Airline crew scheduling, if pilot should be, piloting particular airplane. This is real life examples. Package delivery routes, if this courier should take this particular road to reach those customers. Also real life examples, same with power grid management. And there's a typo, rpush, that's not a thing, that's a push. And that's actually a blog post from Uber, from their tech blog, whatever it's called. And that's it. Thank you for coming. Hope this was interesting or maybe useful in edge cases, but yeah, thank you.
Thank you very much as well, Pawel, for the talk. I don't know anything about fantasy gaming, so it was really cool to have a short look into that world. And we do have some time for questions left, so are there any questions from the audience? No, it was a very clear talk then, apparently.
That's great.
Yeah, I do have a question actually. It's not a technical question, but I was just wondering, like, how long have you been into the fantasy basketball, and how long have you been working on it, and how much money have you made in the in the time?
I made zero money. I don't think fantasy basketball in general in Europe, I don't think it's legal to play on money. You can play for free. I play for free. And this, so first time I started playing 15 years ago, maybe more, maybe 16. Then I had a break, then I switched between different sports, and I came back to basketball more recently. And this got, this is like a side project we try to get done. Some platform for people to get insights into their teams. So yeah, this project came up like 2 years ago. The whole idea of optimization is slightly more fresh. So initial idea for it was I supposed to bring our customers' data and how we can improve them, but we had issue at collecting customers' data, so I have zero. So I could just whatever lineup I had. But yeah, I got as a side thing more like 2 years ago, like trying to solve some fantasy basketball problems since then. Yeah.
Nice. Very cool to hear about it.
Thank you.
Yeah, it's by now not really a surprise anymore, but we do have a gift for the speakers that gave a good talk. So
is it Mac for the Mac situation here?
Yeah, it's for the PyData Eindhoven. Thank you. In his talk, Pawel said that you can go home after his talk. Please don't, because we do have another talk scheduled actually in this room. It's the one that's been moved from this morning, and we're gonna have it in about 5 minutes. So please, be back in 5 minutes or stay tuned.